Let's talk about the new stuff. We're going to call the calculator part of this problem of this unit. So the first thing is that we need to talk about, all right, the change of base formula looks like this. If you've got some log base b of some number a, and it's not log or ln that's on your calculator, you can convert it to ln of a over ln of b, and then you can find the answer for it, because there is an ln button and a log button, but it also works for this. You can do log, which we know is log base 10. You can do log like that, and I can show you the derivation of this in class sometime. It's kind of cool. Anyway, so this is just your basic formula. So if somebody came along and said, oh no, I've got like log base 3 of 13. Well, I don't know what log base 3 of 13. There's no log base 3 button on my calculator. So you can switch that to ln of 13 over ln of 3, or somebody else says, no way, I'd rather do log. It doesn't matter. It's just there's so many things in life that are going to end up being ln. So basically, let's just prove that to ourselves. If I did ln 13 divided by ln 3, I get 2.33, blah, blah, blah. And then somebody says, oh yeah, well, it's going to be different. No, it's not. If I do log divided by log of 3, we get the exact same answer. So 2.3347. And if you look on the worksheets, some of those worksheets are asking you for like 10,000ths, thousandths and 10,000ths place, like 3, 4 decimals. Anyway, so the first set of problems on worksheet 1 are just asking you to do the change of base. I realize some of you, if you've got a really new TI, it will actually do this. There is a button where you can change the base on your calculator. Okay, far out. So that gives you a slight advantage. But anyway, this is going to come up a lot. So let's talk about the whole concept of why we did logs in the first place. And like I said, it's the whole concept of inverses. Like if I had x plus 2 is equal to 10, if I'm trying to solve this, we need x by itself. So we have to do the inverse. So we add the opposite, which is the same thing as, in this case, subtracting. We get x by itself. Or if we had something like 3 to the x is equal to 12, we did its inverse operation, because the whole idea is, therefore, you get x by itself. You do its inverse operation. You get x by itself, which is why we stated they invented logarithms in the first place. Because if I had something like 2 to the x is equal to, I'm going to use something we know the answer to, 8. That's why they came along and said, okay, let's do the inverse, log base 2 of 2 to the x, because log base 2 is the inverse of 2 to the x, therefore the x is left by itself. You do the inverse to the operation. But remember, so therefore you also have to do log base 2 of 8, and we know that that's 3. Anyway, that's why logs were invented. So here's where it's going to get a little fun. If we have something like this, 6 to the x is equal to 3. And I know you're thinking, oh, that's simple. It's got something to do with 1/2. Well, unfortunately, it's not. Here's my recommendation. We got to get the x out of there. You're going to see people do this 2 different ways. My recommendation is this. Do ln to both sides. Do ln to both sides like that. Because we have that rule. We have that rule that says when you've got a log with an exponent, you can bring that to the front and make that into x ln 6 is equal to ln 3. So x ends up equaling ln 3 over ln 6. And then we just have to punch that on our calculator. Now, here's what other people always end up saying. They'll say, well, wait a second, it's 6 to the x. So to get that to cancel out, I would do a log base 6 of 6 to the x. Log base 6, 6 to the x simplifies to just x. Well, you're exactly right. So that means I have to do log base 6 to the other side. But now when I get to this, now I still have to do the change of base formula. Point being, we're in the exact same situation, aren't we? You're going to get the exact same answer. So we would have ln 3 divided by ln 6. So our answer ends up being 0.613. Yeah, 1. 0.6131. Because yeah, some of these are saying they want 10,000ths place. If you wanted to prove that to yourself, prove it to yourself, let's check it. Let's do 6 caret answer, because that's our answer right there. 6 caret answer. And what do you know? It equals to 3. Because that's what we were doing. 6 to the x is equal to 3. So there's our x right there. So 6 to the answer is equal to 3. Far out, it works. Nothing to it, right? It's too easy. Everybody's insulted. Okay, good. Let's do one slightly trickier. What if we had something like this? 7 to the 5n minus 9 is equal to 16. So you're just going to say, oh yeah, duh. We're just going to add 9 to both sides. Me personally, I know some of y'all are going to do, well, I'm going to do log base 7. Far out, do log base 7. I'm going to do an ln to both sides. So we end up with 5n ln 7 equals ln 25. So 5n is equal to ln 25 over ln 7. So n is equal to 1/5 times ln 25 over ln 7. So you'd say, okay, no big deal. I can do this. So ln 25 divided by ln 7. Okay, and then I'm going to multiply. And then how about this? We'll just divide that by 5. So we get 0.3308. So 0.3308. Anyway, not that bad, is it? Not that bad. We can do this. Let's get to some weirder stuff. All right. So some of y'all have been asking, well, what about E? It's 2.7. Well, now we're actually going to multiply it out, because in the previous unit, we left E by itself. We didn't multiply it out, but now we're multiplying out. So we're going to add 3 to both sides. Add 3 to both sides. And I know this is a weird problem. So now we're going to divide by 9.2, and this is going to be all messed up. Everybody ready for it to be all messed up? So 80 divided by 9.2, it's going to be 8.6957. But I'm going to leave this on my calculator right now, because what's our next move here? Well, since it's base E, this is even easier. All I got to do is do an ln to both sides, because it's already base E. So that's going to be ln of this guy right here. And this is already on my calculator unrounded. See, this is going to ln of E to these guys, log base E of E. So these guys are going to cancel and just leave that. This guy right here, I've already got that number on my calculator unrounded. So I'm just going to say ln, and I love the answer button. Ln answer is this guy. So 2.1628, but that's on my calculator unrounded. So then we're just going to end up with A is equal to that answer, whoops, 28 plus 4, all divided by 5. And see, I can do all this on the calculator perfectly accurately. So this plus 4, and then divided by 5, and we get a perfectly accurate answer. There's no need to be rounding these things. No need to be rounding these things. Okay. So anyway, a little bit funkier, but not, horrible, shocking, funky. Okay, now let's do something with an ln. You're thinking, what the heck? Something like this. ln 7 minus ln 4x minus 9 equals 5. And you're like, what the heck? How are we supposed to do this? Well, here's what we do. We know our rule for condensing. So that would be ln 7 divided by 4x minus, and then you're thinking, uh-oh, where do I go from here? Well, here's where you go. What I would recommend, and I know this isn't slick, think of it as, oh yeah, that's log base E. Because like I've said, it's just easier to visualize. It's just easier to visualize when you do this that, oh yeah, we're going to do the conversion. So we're going to have 7 over 4x minus 9 equals e to the 5th. Now it's just an algebra 1 problem. I know, but it's a little funkier, but it's an algebra 1. So 7 equals 4 times x e to the 5th minus 9 e to the 5th. And you're thinking, what the heck? I got numbers. I got letters all over the place. Well, think about it this way. Who are we trying to solve for? Oh, we're trying to solve for x. So I got to get x by itself. So if I was doing this problem, which apparently I am, if I was doing this problem, what I would do is I would add the 9e to both sides. So 7 plus 9e to the 5th is equal to 4xe to the 5th. Now to get x by itself, we're going to divide out the 4 and the e to the 5th. Like that. So it's just algebra 1, a little bit funkier, but just algebra 1. So then we're going to say, okay, here we go. We're just going to do all this on the calculator carefully, very carefully. So I'm going to say 7 plus 9 times, where's my E button? Second ln e to the 5th. So 7 plus 9 times e to the 5th. And I'm going to go ahead and enter that. Okay, now we're divided by 4 caret e to the 5th, close parentheses, like that. And hopefully this is right. I end up with 2.2618. And as always, if we wanted to check our work, that's on my calculator unrounded. So let's check our work. ln 7 minus ln 4 times x, there's my x, so 4 times answer, minus 9, close parentheses, and it's 5. So it checked. All right. So anyway, point being, it's not so bad, is it? This is not so bad. Now, some of the problems you're going to notice when you start working them, some of them are going to be a little bit funkier. The numbers are going to be a little bit funkier, but it's all basically the same stuff. And I hate to keep saying it, but yeah, it all goes back to algebra 1. It's just a lot of algebra 1 problems. Okay. All right. The next stuff is all word problems. We'll get to that.